Okay, we're live. Hey, everybody. While we wait on some people to get logged on, I kind of want to just introduce ourselves and kind of tell you what we're doing. My name is Carly Merrill, and I'm the marketing specialist here at VAC. And with me, I have Scott Kratz. He's our general manager. And with some people working from home or working limited hours, we thought this would kind of be the best way to interact with some of our customers. So we would love for you to leave comments, ask any questions you want to on the right side. And as you get logged in, maybe just drop your name or just say hello. In the description, we have some of our contact information. Our website is available. It has lots of good stuff to check out there. If you have any technical questions or just want to get a quote, give us a call. That's also in the description of the video.
All right. Well, today we're going to start off this little video series. Like Carly had mentioned, we're going to start with simple mounting and calibration of a V200E on a rotary rack and pinion actuator. This particular actuator we're going to set it up clockwise to close, and it is double acting. Like I said, we're going to start off from the basics on this one. We want everybody to get familiar. If you got any questions, please ask questions, and we'll do our best to get those questions answered. And as Carly said, any questions you come up with that you can't ask today, if you watch this video in the future, you can get a hold of us on our website, send us emails, give us a phone call, and we'll do our best to get those questions answered. Upon initially receiving a V200 positioner, we'll come in a box. We'll not have the gauges on it. We've put gauges on it so that we can kind of make this go a little bit quicker. But there's a few other items. When you open the box, there is a spindle in the box. Be sure not to throw the box away without removing the spindle. This happens occasionally. Like we said, we have a double acting rack and pinion actuator that is in the closed position. First, when you pull the position out of the box, we're going to have to install our spindle. If you notice in the back of the positioner, it has a groove in it and a hole for the spindle. When you put a spindle in, it has 2 clicks. So first click, second click. So we have installed our spindle. The next step will be to remove the cover. And we're going to remove our indicator. It's just press fit, so you can just move it back and forth, and it will come loose. The first thing we also want to do is, if you look inside of the positioner, there's a cam lock and a set screw. What we want to do is loosen the set screw, which will be inside of this cam nut. What this will allow and then we're going to loosen our cam nut. What this allows is, when we mount up our positioner, if we need to mount it in a different orientation, we'll be able to spin it without binding the spring inside the unit. So let me mount this guy real quick. So I have set it up. Cam nut is loose. Spindle slot is up and down to go up and down with the shaft. Tighten the bolts. Once you've tightened your bolts, now you can begin tubing the unit. We've got press lock fittings on this unit with a 4 to 20 milliamp unit. 4 milliamps is your zero position. We're going to set this up where 4 milliamps is closed, which is the clockwise position. And for tubing, what we will do is we will make sure that our C- is connected to our driving closed port, and that on our C+ will be connected to our driving open port. That way, as we increase signal, we will be increasing output of C+, and it will drive towards the open position. Supply pressure. Now we're connecting supply pressure. And now we have supply. The first thing you'll want to do before going into calibration is we're going to set our cam. So what we're doing is rotating our cam slightly so that our roller bearing is aligned with a black line and that there is enough room to fit just the tip of a flat screwdriver right in this gap. We'll lock down our cam nut first. Then we will lock down our lock nut or lock screw. Now we have our positioner set. Upon getting this tubed and your cam set, one way to verify that the operation is correct and you've got your pneumatics correct is to reach inside where your pilot valve is and pull down on the pilot valve, and the valve should rotate in a counterclockwise direction, and it does. So we've got it tubed correctly. Any questions? Initially, or most cases, you're going to have in the field, you may not have the luxury of the control room working yet, or in your shop, we're going to use it, as we do here, we're using a generator to generate a 4 to 20 signal. Right now, to calibrate the unit, we start at 4 milliamps. We've got our cam set, and what we're wanting to do is at 4 milliamps, if you look inside of the bottom of the positioner, under the calibration cap, you'll see the range spring. The inside of the spring the cam nut does not need to be tightened with a wrench. It just should be hand tight and then tightened with a screwdriver on the set screw. So back to calibration. The zero screw is in the very middle of the adjustment, and the outer ring, there's 4 vertical slots and 4 horizontal slots. That will be the span adjustment. And these are accessed through the plug on the bottom of the positioner. We have our calibrator set to 4 milliamps, and we're going to be looking at our C plus gauge. At 4 milliamps, we in our C plus gauge on 0. What we'll do is at 4 milliamps, we'll turn our screw, our 0 screw. If I turn the right direction.
And as you're doing that, Scott, we have a question from Dick, and he wants to know, why does the cam need to have a gap at the starting position?
A gap at the starting position allows us to be able to adjust the 0 down. If there is no gap with the cam, it's stuck in that trough. As you try to decrease the 0, you can't do it. It will not be able to move. So it allows for wear in seats, or allows you a little bit of adjustability on the 0 side. Again, we've got our positioner set at 4 milliamps, and we have turned our screw. So you'll see that we're watching our gauge, and we're going to turn this until we're going to turn our 0 to decrease it until the C plus gauge slowly drifts to 0 in about 3 to 5 seconds. Once we have that and we're happy with the way that the 0 is set, we will run the unit to 20 milliamps, and we're going to go through the same procedure, but this time we'll be looking at the C minus gauge. And we will be adjusting the span. So we will be watching the C plus. We'll adjust it until we see the gauge move, and then turn the opposite direction until we drift down to 0 in about 3 to 5 seconds. You can repeat the steps at 0 and span. You can go back and forth and repeat those until you're happy with them. But the 0 and span have very little interaction, and generally, in my calibrations, I will calibrate the 0, I'll calibrate the span, I'll go back and double check 0, and that's generally all it really needs. So you'll see as we went to 4 milliamps, the C minus goes to 0 in about 3 to 5 seconds. Is there any questions so far? We can sort of set our indicator on so you get a little better idea of the unit operating. So we're at 4 milliamps. We're going to give it a 20 milliamp signal. We see our C plus 0 at 3 to 5 seconds. And we're matching on our C minus and our supply. No, this has been.
We do have another question, Scott. This question comes from Randy, and he'd like to know, how would you calibrate the unit if you do not have any gauges?
If you do not have gauges, calibration can be done. We publish a sheet called calibration, V200 calibration of gauges. The reason we want you to use gauges is because it's a repeatable calibration, so that there's no different calibration between different techs. But if you do want to calibrate the unit without gauges, you can do it. It'll have to be done by sound but just by watching the actual cam move as you turn the zero and span screws. So at 0, you'll make sure you're at 0. You'll turn the 0 screw until you see it move. Then you have to back it off until it zeroes back again. And the same process on the C plus.
While you're calibrating it, if you get so far out of 0 and span that it won't react, how do you get back to the factory setting?
We do have on our website, in our technical quick help section, there is a document that we have written up that will show you how to reset this range spring. Basically, without the sheet in front of me, what I'm looking for is roughly 2 to 3 threads showing on the span range here. And what you can do is you can run the 0 until you feel it start to bind, stop. Then turn to reverse directions with your screwdriver and count your turns until you feel it binding the other direction. Once you feel that, what you can do is divide that number by 2 or go back half as many turns the opposite direction. So basically what you're doing is you're setting the 0 in the middle. So as long as that 0 adjustment is set in the middle and you have roughly 2 threads showing on the span, you're going to be really close to factory set. If not, we can make sure you get a hold of the sheet that shows you how to calibrate or reset it. Though this has been a pretty brief setup, calibration, we wanted to start pretty simple and start with the basics on calibrating a unit. Wanted to go over a few things inside the unit. There's really only 2 spare parts that we recommend keeping on your shelf if you need, if you're worried about the service of a unit or making sure it's running. And that's going to be our pilot valve and our I to P. Those 2 units. The pilot valve is oftentimes not needed to be replaced. It can oftentimes just be cleaned by using a CRC contact cleaner, something that's non-residue, and just simple pipe cleaners from a craft store. And oftentimes that's all it really takes to keep it working and operating. The pilot valve, or the I to P itself, generally if it gets full of water, sometimes you can clean it out, sometimes you can back flush it and you can keep it alive, but generally that's the item that will need to be replaced, will be the I to P.
We have another question from Dick, and he would like to know, how does he change the 20th start in 4K? Okay.
All right. Well, we had kind of planned on doing that in a different video, but we'll go over it real quick since we've got a question on it. It's not a bad question. What that will be, it depends on there's several different ways, and you'll have to look in the manual. We have a bunch of different configurations we can set this to operate in. 4 being closed, 20 being open, 4 being open, 20 being, there's several different ways of increasing signal driving closed, increasing signal driving open. But generally, I think what Dick is asking is how to reverse the action. So if we want closed to be 20 milliamps and drive towards 4 milliamps to be open, that would be called reversing the action. And there's really 3 simple steps to that. One step is you have to remove the cam. We would loosen the set screw, remove the cam nut, flip the cam over. We would flip our tubing, and then we would drive. The third step that often gets forgotten is to drive the positioner or the actuator to the new 0 position, which we can do that now. Well, we'll go over that real quick here. Cut the air. What? 60. Like we said, one of the first things we want to do is remove our cam. We're on the C1A side, so we're operating on the 0 to 90 degree, or 0 to 100% 90 degree linear side, where we're going to just flip it over, and we're going to now work on the 0 to 100% 90 degree reverse side. We're going to just run this down loosely, but we're not going to worry about tightening it down because we have not driven to the new 0 position. What we'll do is we'll flip our tubing. We're swapping C plus and C minus. So now the C plus is going to the driving open, C plus is going to the driving open, and C minus is going to the driving closed. And vice versa. C plus to the driving open, C minus. So now the unit is driving to the new 0 position once I pressured it up because of flipping the tubing. We're going to preload the cam as we talked about. Here. Lock the cam down. Give it to me. See, we're having an issue here. Make sure that we're driving to the full open position, which is not wanting to drive. So we're fully open. We're going to set our cam. So as we increase signal, we're going to go towards the clockwise direction. So we're going to set a little bit of preload on the cam. Lock our cam down. C plus will go to driving closed. C minus will go to driving open. Now we have it reversed. 4 milliamps is now going to be in the full counterclockwise direction. And you would adjust your 0 at the now open position. And as we go to 20 milliamps, which is fully closed, we would now adjust the span as the closed position.
Thank you, Dick, for your questions. Those are great questions.
Well, currently, if we're going to give you guys a couple of minutes here to get any more questions to ask. If not, I think we're going to close this particular session out, and we will look at, if you guys don't mind, going to our webpage or go to our YouTube and subscribe. That way, and you can turn on notifications. That way, you know if we're going to schedule a webinar in the future, you'll be able to see it and have an alert for that, knowing that it's coming.
We'll post these on our LinkedIn as well, so make sure you follow us there. And on our Facebook pages, we'll keep you guys updated. And thank you all for joining in. Okay, Scott, we have another question. Someone would like to know if we would be doing a Positioner 101 later on throughout our webinar series. She would like to understand more of the basics of how a positioner actually works.
Yes, we can. That's something we don't really have a complete list. That's something we can add to our list, something we can definitely go over in one of our future webinars is just the basics of the positioner and the concept of how it works and the things that it does. That won't be a problem at all, but yes, we can manage that. And that is one thing to be sure that this is a lot of times a positioner gets mounted on a big piece of steel or iron, but the positioner itself is an instrument. And in Positioner 101, we'll definitely go over and emphasize that it is an instrument. It's not a mechanic, just a big dumb mechanical device.
And can you put the same unit both on a linear and rotary actuator?
Yes, Dick. This particular, our positioners are not dependent upon model to be linear or actuator specific. Any positioner, if we have a mounting kit that will mount one of our positioners, it'll mount any of our positioners. We're looking at the V200 today, but we have a V100, a V200, a D400 digital, and a D500 digital series. The unit, generally all of our positioners are all rotary products, but they can be used on linear or rotary valves depending on the mounting. With a linear valve, we use a mounting kit and design our mounting kits that we convert that linear motion into a rotary motion, which is what the positioner itself is looking for. So yeah, if you look at either side of us, if you look on this side, we have a V200 that is mounted on a linear valve, and on the other side of the table, up in your upper other corner, there is a rotary valve with a digital unit on it. So there is no different version of digital or linear. There are some things that you may look at as changing the cam depending on the amount of rotary stroke you have, but it is the same housing, same positioner, so there's no different model.
Can you talk a little bit about our warranties and kind of touch on that a little bit?
The V200 and the V100 products both have 1-year warranties. We do have a lot of issues out in the field where people want to see they have something happen. It's generally bad air quality, but oftentimes we'll work with our local distributor for the customer and get it returned to us. We'll look it over, see if it is a warranty issue. But we do have an RGA process for warranties, but we do carry a 2-year warranty on the V200 product. And that is from date of sale. Yeah, Dick, we went over this a little bit a while ago, but we'll go over it again. The 2 recommended spare parts are, 1, the pilot valve, which we have a spare pilot valve sitting on the side, and the I to P, so then the current to pressure transducer that's mounted inside the unit. Generally, like we said earlier, the pilot valve can be cleaned. What you want to, generally the test to see if it can be cleaned or not is, as you're holding the pilot valve, if you turn it up about 15 degrees, the stem should slide out, should move freely. If not, you can remove it and clean it with a isopropyl alcohol or some type of alcohol-based cleaner or anything that leaves no residue. You never want to oil or WD-40, tool oil, 3-in-1 oil, anything on the positioner itself. But the other item, like I said, is the I to P. So really only 2 parts that you would want to keep on hand, and you can keep this unit running. Well, guys, we appreciate your time. And like we said, if you've got any more questions, please look in the description of the video. You can get to our website. There's a bunch of good information on the website for technical help. All of our contact information is there. You can email, call, whatever you need. Any questions, we want to be here to help you guys be familiar and comfortable with the product. So with that, I think we will say goodbye to everyone.
Thank you.